Thank you for joining me again, class. Today we are going to focus on 3.2. 3.2 has two different sections, okay? Solving systems algebraically. Now, the first piece, we are going to focus on reviewing solving systems by substitution. Again, hopefully this is review for you. This is something you should have seen in the 9th grade. So, if you recall, the first step whenever we're solving these problems, isolate the variable in either equation. Try to pick a variable that has a coefficient of 1. Now, the coefficient of 1 just makes it easier to manipulate. All right, so that's not a requirement, just something that makes it easier for you. But what you do need to do is get one of the variables by itself. So, looking at equation 1, or example 1, I'm going to focus on that one. All right, because I notice the y doesn't have a coefficient. All right, so that's going to be the variable that I target to get by itself. So I'm going to take that equation, 2x minus y equals 3, and I'm going to get that y by itself. So first thing I'm going to do, I'm going to move the x away from it. So I'm going to subtract 2x from both sides. So negative y equals negative 2x plus 3. And now I don't want my y to be negative. So I'm going to divide everything by negative 1 to get rid of that negative with the y. So I get 2x minus 3. So I have that first step done. I've isolated one of my variables, gotten it completely by itself. And now what I'm going to do is, now that I have y equal to something, y is 2x minus 3. So what I'm going to do is, in my second equation, I'm going to plug that in. I'm going to rewrite my second equation, but instead of writing y, I'm going to plug in that 2x minus 3 because they are exactly the same. So in that second equation, we're going to have 3x minus y. However, remember, we're plugging in that 2x minus 3 for y equals 4. So again, all I've done here is I've isolated that first variable, I've isolated y, and now what it's equal to, that 2x minus 3, I've plugged into the second equation to get rid of the y. Because if you look at what I've got now is one equation with one variable. I'm going to actually be able to solve this equation for x. So, first thing I'm going to do, and notice I had that negative 1 there, so just to make sure I don't make any mistakes, I'm going to distribute that negative 1 through the parenthesis. So I get negative 2x and a positive 3 equaling 4. I'm going to combine my like terms, 3x minus 2x. So that's just going to leave me 1x. So x plus 3 equals 4. Subtract 3. And I get that x equals 1. So we are halfway there. I know what x equals. Now, unfortunately, that's not the end of this problem, because just knowing what x equals isn't the end. The solution to this system, if you recall when we were graphing, we were looking for a point. Well, a point is an x and a y. So what I need to do is I need to put x back into that box that I made. When I isolated y, I made an equation in terms of x. So I'm going to plug that 1 in where x is in that equation. So y equals 2 times x. Well, I know that x is 1 minus 3. So y is 2 minus 3, or y is negative 1. So now I have both pieces. I have my x and I have my y. So when I'm writing this solution, I want you to write these solutions as points. So this solution is going to be the point 1, negative 1. That solves this system. It's true for both equations of this system. So if you reference the top, now we have worked through all of these steps, all right? So again, the top is merely a guide. So if when you're doing these problems after this video and you're confused why I did certain steps, use the top as a guide to show you what to do. Now I'm going to move right into my second example. So again, when we're dealing with these substitution method problems, we need to isolate one of our variables first. Now, in this one, the good news is, if you look at your second equation, one of your variables is already isolated. The x is already by itself. So that is a perfect setup for the substitution. So again, I'm going to take that -4 minus 4y. I'm going to take what that x equals. And in the other equation, I'm going to put it in where I see the x. I am substituting it in for x because they are the same thing. They are equal. So I'm going to rewrite that first equation. So 3 times x, but I don't want x anymore. I want that -4 minus 4y plus 2y equals 8. So now I've rewritten the other equation. I've put in what that x equaled, substituted that into the other equation. So now, once again, I have a single equation with a single variable. So now I'm going to be able to solve for y. First thing I'm going to do, I'm going to distribute that 3. So I'm going to have -12 minus 12y plus 2y equals 8. Next, I see some like terms to combine. -12y and 2y, well, that combines to -10y. And now I just have to solve this like I would any linear equation. To get rid of the 12, I'm going to add it to both sides. So we have -10y equals 20. Well, my y is being multiplied by -10, so I'm going to divide by -10 to cancel that out. So I get y equals -2. So now we are part way there. I have one of my variables, but again, remember, we need both x and y to solve this system. So what am I going to do? Well, I'm going to take that y, and again, I'm going to plug it into that box that I made, because when I plug it in there, that is going to end up solving for x. So we have that x equals -4 minus 4 times y. Well, I already know that y is -2. So when I plug it in there, I'm getting x equals -4, and now -4 times -2 is a positive 8. -4 plus 8 is a positive 4. So I have my x and I have my y. So what am I going to do? I'm going to write it as a point, and that is going to be my solution. That's going to be the end of this problem. So that's the basics of substitution method, all right? Isolating one of your variables, plugging that in to your other equation, solving it, and then going back and solving for the original variable, all right? Now, with all of these, they also come with word problems. So I'm going to take this slide to show you how to solve it when you see word problems. So suppose you bought 8 oranges and 1 grapefruit for a total of $4.60. Later that day, you bought 6 oranges and 3 grapefruit for a total of $4.80. What is the price of each type of fruit? All right, so the first thing that we need to figure out is what we're going to call our variables. All right, now when labeling your variables, what that means is we need to identify what are we looking for. So usually focus on the question. What is the price of each type of fruit? So we're looking for prices here, prices of oranges and prices for grapefruit. So I'm going to let X be the price of the oranges. I'm going to let Y be the price of the grapefruit. All right, so now we have to start constructing equations. Now, when we're talking about cost, all right, cost is always going to come from how many you buy times the price, okay? So I'm going to put that up here. So cost is always going to reference amount times price. And that's always going to give you the cost, how much you're spending. All right, that's going to be key in a lot of these scenarios. So when I'm writing my equations, we are writing money equations. They're giving us how much money we're spending. Well, for 8 oranges, so when I buy 8 oranges, now the cost of that is going to be 8, which is the amount, times the price. Well, the price is that variable that I've already set up, that X. All right, so I'm spending 8X dollars on oranges, and on the grapefruit, I'm buying 1 grapefruit, and each one is Y dollars. So 8X and 1Y led to a total of 460. Now, on the next day, what ended up happening? Well, there I bought 6 oranges. So again, that cost is going to be the amount that I bought, the 6, and the price of those oranges, which is the X, and 3 grapefruit. So the amount times the price, and that time it cost $4.80. And so now we need to figure out what that cost is for each one, that price. Well, we have a system all set up. So, first step, I want to get one of my variables by itself. All right? Now, I'm going to focus on this variable right here, that 1y. Because remember, it's easiest if it has a coefficient of 1, or if it's not being multiplied by anything. So really, all I have to do is transform that equation. If I subtract at 8x from both sides, I have my equation now. I have one of my equations solved for one of my variables. So we already have our ideal setup for solving this by substitution. And that's exactly what I'm going to do. So I'm going to take that, what y equals, and I'm going to plug it into the second equation for the y there. All right? So now it's time for me to rewrite my equation. So 6x plus 3y, but instead of y, I'm going to use negative 8x plus 460, and that's equaling 480. All right, so next thing that I need to do is I'm going to distribute that 3. I'm going to solve this linear equation. So 6x minus 24x plus 13.8 equals 4.8. I have like terms that can combine. 6x minus 24x. Well, 6 minus 24, that's going to leave us with a negative 18. So we have negative 18x plus 13.8 equals 4.8. Next, I'm going to subtract off that 13.8 from both sides. So negative 18x is going to equal 4.8 minus 13.8. We get negative 9. Divide both sides by negative 18, and you get x is 0.5. Now, as you know, we are not quite finished yet. We have our x, but we don't have our y's. So what we need to do, we're going to go and we're going to plug this in to the box that I already made. Because by plugging that in, I'm going to be able to solve for y. So y is negative 8 times x. Well, we know x is 0.5 plus 4.6. Negative 8 times 0.5 is a negative 4. So y ends up being 0.60. Now, for these word problems, I don't want you to just leave the word problems, all right? Don't just leave x and y. The question was, how much did each cost? So I want you to actually answer the question in context. So the oranges are 50 cents, and the grapefruit are 60 cents. So for word problems, instead of writing a point for me, I want you to go back and I want you to answer in context of the problem. So the context is, how much do they cost? Well, the oranges are 50 cents, the grapefruit are 60 cents. All right, let's construct our next equation. So for our next example, a student has some $1 bills and $5 bills in his wallet. He has a total of 11 bills that are worth $31. How many of each type of bill does he have? So again, focus on the question. That's going to tell you how to label your variables. So we want how many of each type of bill. So X, I'm going to have number of $1 bills. Y is going to be my number of $5 bills. And now we need to write our two equations. So the first thing that I'm noticing is total of 11 bills. That word total. Total means sum, added together. So the number of $5 bills and the number of $1 bills is going to add up to 11. Well, the number of bills, that's what X and Y are. So I take the number of $1 bills and the number of $5 bills, X plus Y, and that total is going to be 11. So that's the first piece of information I pick out of this equation. Next, I'm noticing that they are worth $31. All right? So when we're dealing with bills and coins and stuff like that, we're going to get a pretty similar equation to what we did in the first word problem. Because for money, when we're dealing with bills, what you need to know is what it's going to be worth is number of the bills times the value of the bill. Okay, so that's how we're going to construct this, is when we're talking about money. We're going to be talking about how much is the bill worth, and then how many of those bills do we have. So for the $1 bills, so the value of the $1 bills is $1, and we have X of them. So in terms of those, we're going to have 1x dollars. For the $5 bills, they're each worth $5, and I have y of them. So I'm going to have 5y dollars with those. Then altogether, they are worth $31. So I have my two equations. So what that means is I am ready to solve. Now here we have a lot of variables that have no coefficient or simply a coefficient of 1. The one that I'm going to focus on, that I'm going to choose, is that x. So I'm going to subtract y from both sides of that equation to get my new equation, x equals negative y plus 11. So I've done my first step. I have one of my equations isolated for one of my variables. So now I'm going to go into my other equation, and I'm going to plug it in. So for the second equation, I have x, which I'm now calling negative y plus 11 plus 5y equals 31. And again, now I have a single equation with a single variable, so I can actually solve for it. Now here, there's nothing to distribute, so I can just start combining my like terms. Negative y plus 5y, that's going to give me 4y. I can subtract 11 from both sides. 4y equals 20. Now finally, I need to divide by 4, and that's going to give me y equals 5. So I have one of my variables solved for, but remember that isn't enough. We're not done yet. I need to take that, I need to plug it in to the box I made to get my other variable. So x equals negative y. Well, we already said y is 5 plus 11. Negative 5 plus 11 is going to be 6. So x ends up equaling 6. So now I've done it. I have both my variables solved for. But again, in these word problems, I don't want you to write them as a point. I want you to solve it in context. So the student has 6 $1 bills and 5 $5 bills. Again, for these word problems, I want you answering in context. So that is the answer that I'm looking for. What is in blue? All right, so thank you for joining me for this. I realize there's a lot to write down here, but please make sure that you have all of these notes finished and ready for me to check in class, and then we will continue with our practice work. So again, thank you for joining me, and I will see you in class.